Welcome back. Today we're going to be talking about the area of irregular and composite shapes. The content objective is students will be able to find the area of irregular and composite shapes. Language objective is students will be able to discuss how to break apart a composite shape into shapes that you are familiar with. Why am I learning this? Well, it's important for real-world problems like figuring out how much wood is needed to build a patio deck. So first, let's go over some background knowledge. Here, what is the circumference? First, it's good to understand that the circumference is simply the distance around the circle. So it's just focused on in this case, you could think of it as the outline of the circle. So how do we find the circumference of a circle? You simply take pi and multiply that by the diameter. But then we also have area. How do you find the area of a circle? Real quick, area is basically the space inside the shape. So how do we do that? Well, we do that by taking pi and multiplying it by the radius squared. So keep those two formulas in mind because we will definitely be utilizing them today. So we are focusing our attention on irregular or composite shapes. So first, I want you to look at these shapes here. We know how to find the area of a full circle. Well, what about these? Okay, first, hopefully you recognize that this is half a circle. So what would I do? I would find the area of the full circle, and then I would times it by a half, or I can simply find the area and divide by 2. What about this shape here? Well, this shape is 3/4 of a circle, so I'd have to find the area of a circle and multiply by 3/4. Now, are there other ways of doing it? Yes, but this is what comes to mind first. So here, well, I would describe this as 1/4 of a circle. So what would I do here? Well, I would find the area of a circle, and I would multiply it by 1/4, which is 1/4. So keep this in mind because it will definitely come in handy throughout the lesson today. Number 1, it says a corner shelf is in the shape of the picture below. It has a radius of 5½ inches and is 1/4 of a circle. Find the area and round your answer to the nearest hundredth. So, how am I supposed to find the area of this shape right here? Well, we do know it's 1/4 of a circle. So, what I'm going to do real quick is draw this figure for you so you can kind of visualize it. If you were to draw a circle, pretend it's perfect. I know it's not. Hopefully you can recognize that this here, the bookshelf, is exactly 1/4 of a circle. In fact, it was even stated in the instructions right here. So what should I do? Well, if it was up to me, I would find the area of the entire circle and simply take 1/4 of it so I can figure out exactly what the area is of this shaded area. So let's first start with that. We're going to find the area of the circle. So area equals pi times the radius squared. So what is the radius? Well, the radius is 5.5. So let's put pi times 5.5, and we're going to square it. Then we're going to go ahead and say, okay, let's leave this as pi for right now. 5.5 squared is 30.25. Since they're asking us to round to the nearest hundredth, what I'm going to go ahead and do is I'm going to write out pi as 3.14 instead of using the symbol, but we're still going to multiply that by 30.25. So what does that give me? Well, that's going to give me a total of 94.985 inches squared. So, I'm not done yet. Why? Because this is actually the area of the entire circle. And I'm not interested in finding the area of the entire circle. I'm specifically concentrating on this 1/4 of a circle. So am I done? The answer is no. What I will have to do now is I'm going to take the area of the entire circle, which happens to be 94.985, and I'm going to take 1/4 of it, which is 1/4. what you're going to find yourself doing is a quick way is basically you're going to divide by 4. But you can even see here that this times 1 is the same and 1 times 4 is 4. Now we're going to divide that, and that's going to lead us to an answer of 23.74625. But let's go back into the instructions for a second. They did ask us to round to the nearest hundredths, so that's exactly what I'm going to do. Here's the tenths, here's the hundredths. The 6 is going to make the 4 go up, so my final answer is going to be 23.7 instead of a 4. We're going to make it go up 1, which is going to be 75 inches squared. So the area of this bookshelf, which happens to be a quarter of a circle, would be 23.75 inches squared. Number 2, it says, how would we find the circumference of this shape? Well, let's take a look at something here. We know this length already, it's 5.5, and we already know this length here, which is also 5.5. Now the only thing that's missing is this length here. So how do I find this missing length? Well, we're going to do exactly what we did earlier. We're going to think of it in terms of a full circle. Okay? Specifically, this here is just 1/4 of the entire circumference of this circle. So what we're going to do is just like before, we're going to find the circumference of the entire circle, but just to focus just on this purple part, we're going to only take 1/4 of it. So let's do that. We're going to find the circumference by taking the diameter and multiplying it by pi. So here the circumference is diameter. What's the diameter? I know the radius is 5.5, so this other half should also be 5.5 inches, which would mean the entire diameter of this would be 11. So we're going to do 11 times pi. Now what we're going to do is replace pi with the value 3.14. Once we multiply that out, we're going to be left with 34.54 inches. Since it is circumference, we don't put squared. It's just inches by itself. So here is actually the circumference of the entire circle, but I'm only interested in finding 1/4 of it because I want to find this missing length. So what I'm going to have to do is take 1/4 of this. So how do I do that? Well, I'm going to take the circumference and I'm going to multiply by 1/4, which ends up having you just divide by 4. Once you divide by 4, you're going to end up with 8.635. So this here is 8.635. Why? Because it's exactly 1/4 the circumference of the original. So now that I have that, what I'm going to do is I'm going to add up all the lengths of this bookshelf. So let me just go ahead and erase some of this stuff so that we can have a clear slate. So here we go. First, we're going to add this length here, which is 5.5. Then we're going to add this length here, which is also 5.5. And last but not least, we would have to add this length, which is 8.635. So one thing to remember is we already figured out what 5.5 plus 5.5 is. We did that to figure out the diameter. It was 11. What is 11 plus 8.635? Hopefully you can do that in your head. It's basically 19.635 inches. So that would be the circumference of this shape. So what did we do exactly? We basically found the distance around this entire bookshelf. Number 3, it says, the circumference of the circle below is approximately 125.6 centimeters. The shaded region is 3/10 of the whole circle. What is the area of the shaded region? Now round to the nearest hundredth if necessary. So what they're asking us to do is to find the area of the shaded area, which is 3/10 of it. So in order to find the area of this, I am going to have to first find the area of the entire circle. So that would require me to do pi r squared. But let's think for a second. I would need radius for this, and the radius was nowhere mentioned in the information given. So what could I do? Well, I got to work with what I'm given. They told me the circumference is 125.6, and that's pretty important information. So what we're going to do first is start with the formula. The circumference is derived by taking the diameter and multiplying it by pi. So if you've already figured it out, what my plan is to solve for diameter, because once I find diameter, I'd be able to figure out the radius, which will allow me to plug it into my formula here. So let's do that. I'm going to say the circumference is 125.6 because that's what's given, so I'm going to write that in. And that's going to equal the diameter times pi, which I'm going to replace pi with just 3.14. So in order to solve for d, since this means multiplication, I'm going to have to divide both sides by 3.14. If I do that, I'm going to be left with the diameter equals 40. So what that means is this entire length is 40, because that's the diameter. But to use my formula here to figure out the area of the entire circle, I'm interested in finding the radius. So what is just this length right here? Well, it would be half of the diameter. So I would say the radius is half of the diameter. Half of 40 is 20. So this is actually very helpful information. This is the one piece that I still needed. So now that I have the radius, I can go ahead and find the area of the entire circle. So let's do that. We're going to go ahead and put pi. Let's go ahead and replace pi with 3.14 right now. I am going to replace the radius with 20, and we're going to square that. So we're going to leave 3.14, and then we're going to simplify 20 squared as 400. If you multiply this out, you will end up with 1,256 centimeters squared. Now, that's great, but I'm not done. Why? Because I essentially found the area of this entire circle, but I'm not interested in finding the area of the entire circle. I'm more interested in finding the area of the shaded circle. So they did tell me that the shaded area is 3/10 of the whole circle. So what should I do? What I'm going to do is I'm going to take the area of the entire circle, which is 1,256, and I'm just going to take 3/10 of it. Here, we're going to multiply straight across, but before I do that, if I were you, I would cross cancel by 2, leaving me with 628. So if you multiply 628 by 3, you would end up with 1,884 over 5. Now, if you divide that out, you will end up with 376.8. In this case, it would be centimeters squared. So what is the area of this shaded section in the circle? It would be 376.8 centimeters. Again, you had to find the area of the entire thing and simply take 3/10 of it because that's what was shaded. Here it says, what different shapes make up these composite shapes? Well, let's take a look. There are several ways you could think of it. This one here, I can imagine it as being one rectangle plus one square. Okay, now is there another way you could have possibly cut up this shape? Absolutely. Some of you may have seen it like this and said, oh look, it's a rectangle combined with another rectangle. So does it really matter how you cut up the shape? No, but you do want to try to keep it within a shape that you know how to find the area of. So for example, could you possibly cut it like this? Yes. Because this is a trapezoid, this is a trapezoid. Now, if I were you, I would stick with what's easier. So for example, rectangle and square might be easier than finding the area of one trapezoid and the area of another trapezoid. So just be careful on how you cut up the shape because there are multiple ways to do that. Now for this shape here, what do you see? Well, for me, I see a semicircle, or aka half a circle, mixed with a rectangle, or in this case, a square. So keep in mind once again that it doesn't matter how you cut it. However, you do want to cut it into a shape that you actually know how to find the area of. So once again, if I decided to cut it this way, unfortunately, I don't know what this shape is called. Therefore, I don't know what the area is. I can't calculate it. So there are good ways to cut up a composite shape, and there are ways that might not be helpful at all. So here, why don't you pause the video and try to figure out what shapes make up these composite shapes. So here, I came up with a rectangle and a triangle. Okay, what did I come up here? Well, I went ahead and cut it this way, and I noticed that it was a trapezoid with a square. So now that we've gotten pretty good at cutting up the shapes into other shapes that we're more familiar with to find the area of, let's do some practice. For number 4, it says, Samantha is looking down at the hotel pool from her 10th story window. She is wondering what the area of the pool's floor is. Help her find the area of the pool's floor. So we are given some dimensions. We're given that this length here is 12, this length here is 16, this length is 9, and this length is 8. So first things first, what I'm going to do is I'm going to cut up this shape into 2 more familiar shapes that I can find the area of. So I'm going to cut it here. Now, it's been cut up into 2 different rectangles. Some of you might be saying, wait, Miss Ane, that's not a rectangle, that's a square. Why did I say rectangle then? Why? Because I noticed it's an 8 by 9, which means these dimensions aren't exactly the same. So it technically is a rectangle. So to find the area of this rectangle here, I'm going to do base times height. The base is 8, the height is 9, so the area of this rectangle is 72. Now I'm going to have to find the area of this rectangle here. I know the base is 16, however I don't know the height yet. So what should I do? Well, I'm going to stick with what I know. I'm going to use what I know to figure out some missing details. I know this entire length is 12. I know up to this point it's already 9. So what is this missing piece? If it helps, what you could do is think of it this way. This length here is 9. So from here to here, this is 9. Okay? But this whole thing is 12. So what's this missing length right here? Hopefully you've guessed it correctly and you said that it's 3, which makes this 3 as well. So to find the area of this rectangle, I would do base, which is 16, times the height, which is 3, which would give me 48. So now that I have that, I'm going to go ahead and find the area by combining both of these 2 shapes. We're going to add 48 with 72, and that's going to give me 120 meters squared. So some of you might be thinking right now, wait a second, how did you get that? What if we wanted a different way? Could we still get the same answer? The answer is yes. So instead, what could we have done? Let's see. Another option is, instead of cutting it this way, you could have cut it this way. So let's work this out. Here, the base is 8, the height is 12, so the area here would be 96. But then I still need to find the area of this shape here. Well, hopefully you remember this is 3. So how do I find this missing length here? Well, I understand this full length is 16. And I know this length right here is 8, which makes this length here 8. So if this is 8, this length here must be 8 as well. Why? 8 plus 8 will give me this full length of 16. So now that I know the dimensions, I'm going to do the base, which is 8, times the height, which is 3, which would give me 24. So I'm not done yet because I need to find the area of the composite shape by combining both of these 2 together. So you would do 96 plus 24, which would also give me 120 meters square. So does it really matter how you cut up the shape? No. But I'm not sure if you caught this, the first method of cutting up the shape was actually easier because I only had to know this missing length. Cutting up this length required me to find this length and this length as well. So keep that in mind when you are cutting up the shape. Try to cut it the easiest way possible. Now on to number 5. It says find the area. So once again, there are various ways that you can cut up this shape. However, for me, I do think it would be the best if we cut it this way, which would require me to find the area of a triangle, which I know how to do, and the area of a rectangle, which I'm also pretty familiar with. So to find the area of the rectangle, I'm going to do base, which is 12, multiply it by the height, which is 4. So the area of this rectangle is 48. But now I'm going to have to find the area of this triangle. So let's see. There is some missing information that I must figure out before I plug in my numbers into the formula. I am missing the base. However, I do know that this whole length is 12, and I do know that from here to here it is 8, which means from here to here it's 8. So what must this extra piece be? Well, it should add up to 12, so I would say that this extra piece must be 4. And I can prove it to you because 4 plus 8 would give me the complete distance of 12. Now I need to find the height of this triangle. It's not a 10, so again I'm going to have to figure this out. First, I'm going to start with what I know. I know this entire height is 10, and I also know that from here to here it is 4, which makes this length from here to here 4. So what must this missing height be? Well, if this is 4, let me write that in, then this whole length should have to be 6. Why? Because 4 plus 6 would give me this full length of 10. So I'm just going to go ahead and redraw this triangle real quick. I know the base is a 4 and the height is a 6. So I'm going to find the area of this triangle. To find the area of a triangle, you're going to do base times height, and then you're going to divide by 2. To make things simple, I am going to cross cancel. I'm going to go ahead and divide by 2. And that's going to leave me with 12 over 1, which is just 12. So I'm going to erase everything for a second except the area that I've already figured out. So far I know that the rectangle has an area of 48 and the area of the triangle is 12. So to find the area of this entire shape, I'm going to have to combine 12 with 48, which is going to leave me with a total of 60. But let's remember, we need to use the correct unit, so I would say the area of this composite shape is 60 feet squared. Now looking at number 6, it says find the area of the patio deck below. So here's the thing. I think what's going to be misleading is some of you are going to be tempted to cut up the shape like this just because you see a dotted line here. I'm going to recommend that you look at it as if that dotted line wasn't there, because if it was up to me, I would not cut it like that. In fact, I would decide to cut it this way. Why? Because then it just becomes a trapezoid and a rectangle, which would make it pretty easy for me to find the area of. So to find the area of this rectangle here, I'm going to go ahead and take the base, which is 36, and multiply it by the height, which is 14, which is going to give me a grand total of 504. So that is the area of the rectangle. But we're not done yet. We still need to find the area of this trapezoid. So how do we find the area of a trapezoid? Well, it's very similar to finding the area of a triangle. You simply take 1/2 times the base. Now the only thing to keep in mind is with a trapezoid, there's 2 bases. Base 1 plus base 2. And then you're going to multiply it by the height. So let's go ahead and start filling this out. What is the first base? I'm going to go ahead and say that the first base is 20, so let's write that. And we're going to add that to the second base. What is this base right here? Well, this one's exactly the same length as this here, So I would say it's 36. And then we're going to multiply by the height. Now here is where you have to be careful. Okay, so I know that this full length here is 20. I also know that from here to here, that is 14 centimeters. So if I know this is 14 and this whole length is 20, this missing piece, let me use a different color, this missing piece here, let's color it yellow, would have to be how much? Hopefully your answer is 6. Why? Because 6 plus this 14 would give me a grand total of 20. So we're going to go ahead and say that the height is 6. So let's simplify this out. I'm going to move it up here because I have more room. We're going to have 1/2 20 plus 36, which is going to give us 56, times 6. If you want, you can kind of do this so you can cross cancel. You could have cross cancel with the 56 or the 6. 6 is just easier for me, so that's what I'm going to choose. Cross cancel by 2. If I multiply 56 times 3, I'm going to get a total of 168. So that would be the area of the trapezoid here. But let's remember, we're not done yet. We want to find the area of the entire patio, just not this section and this section alone. So we will have to combine 168 for the trapezoid plus the 504 for the rectangle. When you combine those, what you're going to end up with is a grand total of 672 feet squared. Okay. So now that I know the area of this of this patio deck, what if they asked an extra question? They said, if the cost of the wood deck below is $5 per square foot, find the cost of building the deck below. Well, how many square feet do we have? We have 672 square feet. And it does cost $5 per square foot. So what do we have to do? We're going to have to multiply. You'll notice here, feet squared cancel out. So if you multiply by 5, it's going to give us a grand total of 3,360. You'll notice we're left with the units of dollars. So I would say it's going to cost $3,360 to build this deck just for the material alone. Okay, so now this is more for an extension. If I was asked to find the area of the shaded region, what would I do? Well, I would first start with finding the area of the entire circle. Okay, so if I had to find the area of the entire circle, I would go ahead and say, hey, this radius is a total of 4 meters. So let's do that. We're going to say that the area of the larger circle is pi 4 squared, which leaves me with 16 pi. I'm going to leave it like that for a second, and I'll explain in a moment why I would do that. Now, what would I do? Well, to find the area of this shaded gray region, what I would have to do next is simply get rid of this circle right here. So how would I do that? Well, I'm going to have to find that area so that I can subtract it, because notice that's exactly what I did. I erased it. I got rid of it. So let's do that. We're going to find the area of the smaller circle. Let's change the colors. So the area would be pi radius, which in this case the radius is only 2 squared. So that's going to leave me with 2 squared is 4, so that would be 4 pi. So the area of the larger circle is, let's say, 16 pi. But then what we did is we took out the area of the smaller circle, and this is not going to be exact, but just giving you a rough estimation. Okay, we found the area of that inside circle, which happens to be 4 pi. So what do we do to find just the shaded area? Well, we'd have to subtract. So 16 pi minus 4 pi is going to be 12 pi. So what is the area of the shaded region? Well, it depends. If you want it as an exact answer, I would just say 12 pi. But if they ask you to estimate, I would go ahead and take 12 and multiply that by 3.14, which is going to be approximately 37.68 meters squared. So there you have it. Guess what? That actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.